Now, once we calculate a prevalence or an incidence, we might want to compare different groups. So a question we might ask is, how much difference in risk is there between an exposed and unexposed groups? Now, these terms exposed and unexposed we're going to see come up frequently. Exposed we could think of just as a generic term, meaning that a group has some exposure to something that could potentially cause the disease, whereas an unexposed group is not exposed to that same thing. So we're going to look at different ways of comparing groups. The first one is, or the first way of comparing them is with what we call a risk difference, abbreviated RD. And this is very simple. We're going to calculate the difference in prevalences. Take the prevalence of the exposed group minus the prevalence of the unexposed group, hence the name risk difference. Okay. So let's look at this data here regarding cardiovascular disease and two groups, non-smokers and smokers. So we could think of smokers as being exposed and non-smokers as being unexposed. And so let's calculate the risk difference of smokers versus non-smokers. So we're going to take the prevalence in the exposed group, which is smokers, minus the prevalence in the non-smokers. And so we need to calculate these individual prevalences. So the prevalence of the smokers is the number of smokers who have a history of cardiovascular disease, 81, divided by the total number of smokers, which is 744. Prevalence of non-smokers is the number of non-smokers with a history, 298, divided by the total number of non-smokers, which is 3055. We do this arithmetic and we get a difference of 0.0114. Okay, so what does this number mean? The risk difference is 0.0144. So this means that the difference in the prevalence of cardiovascular disease between smokers and non-smokers is 0.0114. So what does that mean? Well, we could think of this as that in smokers, the prevalence of cardiovascular disease is 1.14 percentage points higher. So percentage point is just the percentage equivalent of a decimal. So we move this over two places, we get 1.14. So prevalence in smokers is 1.14 percentage points higher than non-smokers. The next question, or next idea we're going to talk about is called the population attributable risk. And so the question we might ask is, what proportion of the total cases of a disease are attributable to a factor? So if we think back to our last example where we looked at cardiovascular disease and smoking, smokers had a higher prevalence of cardiovascular disease. And so a question we might ask, well, just what proportion of cases of cardiovascular disease are attributable to that factor of smoking? And so we're going to measure that with this population attributable risk, which is abbreviated PAR. And so we're going to take the overall prevalence minus the prevalence of the unexposed group and divide it by the overall prevalence. Okay. So let's apply this back to this example of smoking versus non-smokers and cardiovascular disease. So the population attributable risk is going to be the overall prevalence minus the prevalence of the unexposed group, which is non-smokers, divided by the overall prevalence. So we need to calculate these individual prevalences. So the overall prevalence is we'll take the total number of people who have a history of cardiovascular disease, the 379, and divide it by the total number of people, 3799, and that's my overall prevalence. And we're going to do that the same in the denominator. Now the prevalence of non-smokers, we're going to take the number of non-smokers with the history, divide it by the total number of non-smokers, 3055, and that's my prevalence in non-smokers. So we do that arithmetic, we get 0.022, or the same as 2.2%. So what does this mean? Our population attributable risk is 2.2%. This means that 2.2% of the prevalent cases of cardiovascular disease are attributable to smoking, at least according to this definition. So what that means in other terms is that these cases could be eliminated if the exposure to smoking were eliminated, at least in theory if we take a very narrow view. So we could eliminate 2.2% cases of cardiovascular disease if we eliminate this exposure to smoking. Okay. Let's look at another way of comparing groups. And this next way is what we call the relative risk or the risk ratio. And these are some terms that we're going to see come up later on in the semester, and we'll see them in our journal readings. So the relative risk, abbreviated RR, is simply the prevalence of the exposed divided by the prevalence of the unexposed. And so let's again look at this data of smokers and non-smokers versus history of cardiovascular disease. So the risk ratio of cardiovascular disease in smokers versus non-smokers is going to be the prevalence of our exposed group, which is smokers, divided by the prevalence of the non-smokers. And so we need to calculate these individual prevalences. The prevalence in smokers is the number of smokers with a history divided by the total number of smokers. That's how we get our numerator. The prevalence of non-smokers is the number of non-smokers with a history divided by the total number of non-smokers. That's how we get our denominator. We do that arithmetic, we get 1.12. So what does this risk ratio mean? Kind of informally, a smoker is 1.12 times more likely to have prevalent cardiovascular disease than a non-smoker. Another way of comparing groups is with what we call the rate ratio. The rate ratio is the incidence rate of the exposed divided by the incidence rate of the unexposed. So here we're calculating incidence rates rather than prevalences. And so let's look back at this data of regarding gender and cardiovascular disease, where we had a total of 190 men develop cardiovascular disease with a total of 9,000 years that were disease-free. We had 119 women develop cardiovascular disease and a total of 12,000 years of those women in which they were disease-free. So we calculated the incidence rates of these different populations or these different groups earlier. 190 divided by the 9,000, we got this incidence rate, and then they take the 119 divided by the 12,000, and we got this incidence rate for women. And so to calculate the rate ratio of men to women is we'll take the incidence rate for the men and divide it by the incidence rate of the women. So we'll kind of interpret being a man as like being exposed to a cardiovascular disease. Now whether that's really a proper interpretation or not is maybe up to debate, but for purpose of this exercise we'll just call that the exposed group divided by the unexposed group. We do that arithmetic and we get 1.94. Okay, so what does that incidence rate of 1.94 mean? Well, the incidence of cardiovascular disease is 1.94 times higher per person year in men as compared to women. All right, so what does that mean in less formal terms? Informally, men are 1.94 times more likely to develop cardiovascular disease than women. Remember, incidence has to do with kind of likelihood of getting the disease, not getting the disease in the future, as opposed to prevalence, which deals with having the disease at a point in time.